On March 29, 1990, the United States Environmental Protection Agency published its final revision to the toxicity characteristics portion of RCRA. This final ruling requires the use of the new toxicity characteristic leaching procedure, TCLP, to evaluate all unknown waste for toxic constituents. The bottle TCLP requires a 142 millimeter hazardous waste filtration unit with a 1.5 liter extension barrel. All contact surfaces are Teflon lined to assure that no chromium is extracted from the stainless steel. The required filter media is a binderless glass fiber filter 142 millimeters in diameter. Each filter should be nitric acid washed prior to use. After the filter is in place, reassemble the filter unit. Once the top plate is tightly secured, a representative 100-gram sample is introduced into the top flange fitting of the filter holder. This sample should have been pre-evaluated for particle size, pH, and percent dry solids. This step is critical in determining the volume of extraction fluid needed to run the extraction step. After pouring the 100-gram sample into the filter holder, secure a compressed air line to the top inlet flange fitting. Starting at 0, apply direct pressure to the waste sample in 10 psi increments, holding at each 10 psi increment for a full 2 minutes. Collect any liquid expressed out of the filter holder during this pressurization. Continue pressurization until 50 psi is reached or until air starts to pass through the filter, whichever occurs first. The liquid expressed out during this pressurization is called the primary leachate. This liquid sample may be evaluated immediately or stored at 4 degrees Celsius for final analysis. After the initial liquid is collected, remove the air line from the filter holder assembly. If during the preliminary evaluation it was determined that the sample contains more than 0.5% dry solids, then the solid fraction of the waste must be leached with a 20x volume by dry weight of extraction fluid. After separation of the solid and liquid fractions, disassemble the filter holder. The used filter and the dry filter cake are removed from the filter holder and transferred into a 2-liter bottle for extraction. The extraction fluid of choice is based on the pH of the waste. If the waste has a pH less than or equal to 5, extraction fluid number 1 is used. If the pH of the waste is greater than 5, then extraction fluid number 2 is used. These solutions should be made up fresh daily. Measure out a 20x volume of the appropriate extraction fluid and decant it into the extraction bottle. Cap the bottle and take it to a rotary agitator. For bottle TCLP, the rotary agitator must rotate the bottle end over end at 30 revolutions per minute, plus or minus 2 revolutions per minute, for 18 hours. This step ensures thorough extraction of the contaminants. At the end of the 18-hour extraction period, stop the agitator and remove the bottles. The next step in the procedure is to filter the tainted extraction fluid. A new nitric acid washed binderless glass fiber filter is placed in the 142 mm filter holder. Secure the top plate with the hand wheels. Use the wrench to make sure the top plate is tightly sealed to the extension barrel. Introduce the contents of the bottle into the filter unit. This second filtration step separates the extraction fluid from the solid sample. After the entire contents of the extraction bottle have been added to the filter unit, attach a compressed air line to the inlet flange of the top plate. Once again, apply direct pressure to the sample starting at 0. Increase the pressure in 10 psi increments. Hold the pressure constant at each 10 psi increment for a full 2 minutes. Collect any liquid expressed during this filtration step. Continue pressurization until 50 psi is reached. The liquid expressed during this pressurization is referred to as the secondary leachate. This secondary leachate, together with the primary leachate obtained earlier, is collectively called the TCLP leachate. If these two samples are compatible, they can be physically combined and analyzed. In the event they are not miscible and their combination would result in a multiphasic solution, the samples should be analyzed separately and the result should be mathematically combined. To evaluate wastes for the presence of volatile organics, the ZHE TCLP is used. The zero headspace extractor is a 90 mm filter holder with a 500 milliliter extension barrel which contains a piston. When the filter unit is pressurized from below, the piston rises, eliminating the headspace and enhancing filtration. Because of its smaller size, the ZHE filter unit requires the use of a smaller representative waste sample. A 25-gram sample is used for the evaluation of volatile organic hazardous waste by the ZHE TCLP. As with a bottle TCLP, the sample should have been pre-evaluated for particle size, pH, and percent dry solids. Prior to loading the representative 25-gram sample into the filter holder, insert the piston into the barrel. Pre-wet the O-rings on the piston with extraction fluid number 1 and insert the piston with a pusher. Put the loaded barrel on the base plate and pour the 25-gram sample of waste into the barrel on top of the piston. As in the bottle TCLP, a nitric acid washed binderless glass fiber filter is placed between the two support screens. The sandwich of the support screens and the filter is placed in the top plate. Use the top O-ring to hold them securely in place. Secure the top plate with the hand wheels. Use the wrench to tighten the hand wheels. Connect a compressed air line Connect a compressed air line to the gas fitting at the bottom of the filter unit. In a hood, purge the head space out of the ZHE by opening the top valve. This head space should be removed with less than 15 psi of pressure. At the first sign of liquid, close the top valve. After removing the head space, connect a collection device such as a gas-tight syringe to the valve on top of the unit. Starting at the initial pressure used to eliminate the head space, increase the pressure in 10 psi increments. Hold the pressure constant for 2 minutes and collect any liquid which is expressed out into the syringe. Then increase the pressure another 10 psi and wait another 2 minutes. Continue up to a maximum pressure of 50 psi. This liquid is referred to as the primary leachate. This leachate may be evaluated immediately or stored at 4 degrees Celsius for future analysis. If the percent dry solids of the sample exceeds 0.5%, the waste should be leached. All waste evaluated for volatile organics should be extracted with a 20x volume by dry weight of extraction fluid number 1. The extraction fluid must be introduced in such a way as to prevent the addition of ambient air. A 5-liter pressure vessel may be used to hold the 20x volume of extraction fluid and pump it into the zero headspace extractor. Connect the outlet of the pressure vessel to the valve at the top of the ZHE. Pressurize the 5-liter vessel and release the air pressure from below the piston in the ZHE. This will allow the piston to move down as the barrel fills with extraction fluid. After the ZHE fills with extraction fluid, disconnect it from the pressure vessel and take it over to the rotary agitator. Load the ZHE into the rotary agitator, making sure it is properly balanced. For ZHE TCLP, the rotary agitator must rotate end over end at 30 revolutions per minute, plus or minus 2 revolutions per minute, for 18 hours. This ensures thorough extraction of trace amounts of contaminants. At the end of 18 hours, remove the zero headspace extractor from the rotary agitator. The next step in the procedure is to remove the extraction fluid from the ZHE. Reattach a compressed air line to the bottom of the ZHE. Connect a collection device such as a Tedlar bag to the top fitting. Increase the pressure applied to the bottom of the unit in 10 psi increments. Hold the pressure constant at each 10 psi increment for 2 minutes. Collect any liquid expressed during the 2-minute interval. Increase the pressure in 10 psi increments to a maximum of 50 psi. This secondary leachate, together with the primary leachate obtained earlier, is collectively called the TCLP leachate. If these two samples are compatible, they can be physically combined and analyzed. In the event they are not miscible and their combination would result in a multiphasic sample, they should be analyzed separately, and the result should be mathematically combined.